Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS exam. We are focusing on ISS 2026 and we have completed a major portion of statistics paper 3 which is of descriptive type and the topic is econometrics. Now we are currently doing sampling techniques. We have covered simple random sampling with replacement and without replacement and stratified random sampling as well. Today we will start with systematic random sampling. So let us begin. Systematic sampling or systematic random sampling, anything can be, it can be called with any name. So it is the part of probability sampling only, and it is a new form of simple random sampling, advanced version of simple random sampling. So what do we do if we have some people? Suppose if we have to take the interview of some people, of some random people walking on the street. So let us take three kinds of people. This is a population of some random people. Let us suppose they are, the size of this population is capital N is equals to 80, and we have to interview a few people. So in systematic random sampling, we will see what is the number of sample we have to draw. Suppose if we have to draw a sample of size 6, or let it be a sample of size 3. No, let it be 6 only. A sample of size 6. If we have to draw a sample of size 6, so we will take k. K is the sampling interval. We will talk about this later. Just understand what is the concept of simple systematic sampling. So k is nothing but 18 divided by 6, which is 3. So the sampling interval is 3. Now we can choose any any first sample unit. Let us choose that I am choosing this one, number 3. So this is my first sample, and after this, every third interval I will choose a new sampling unit. So 1, 2 and 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. How many samples have we drawn? We have drawn 6 samples. Okay. So now here we see that the red people, or let us name them the males. The red peoples are 3, and out of 6, the red peoples are 3. The orange people are 2, and the purple people is 1. So this tells us that there is biasness in the sample. This is the basic concept of systematic random sampling. Okay, systematic random sampling can also be defined when, suppose we have to take, there are 1000 students in a school and we have to take a sample of 100 students. So capital N is 1000 and small n is 100. So our k, which is the sampling interval, will be 10. So every 10th student will be selected and that will become our sample. That is also one of the case of simple random sampling. But but there is bias, there can be biasness in the sample. Now how do we choose a sample of size small n for in systematic sampling? For choosing a sample of size small n, the first step is choose any number between 1 to k. Now we have to choose from any number between 1 to k. Suppose in the previous example, the k was 6, so we chose number 3. And then second, choose the first unit randomly. Third is, suppose the chosen unit is I. So the sample or systematic sample would be, first one is I, then second one is I plus k, then third one is I plus 2k, up till I plus n minus 1 k. This will be our systematic sample. Let us apply on this example. So we chose I is equals to 3 here. So we chose the third unit first. Then after that I plus k, which is 3 plus 3 is equals to 6. So sixth unit is selected. Then I plus 2k, ninth unit is selected. I plus 3k, 12th unit is selected. I plus 4k, 15th unit is selected. And I plus 5k, 18th unit is selected. This is how the sample is selected. Now there is one more thing. This sample is systematic sample. What are some important points of systematic sample? So in systematic sample, first unit is selected randomly and rest others are first is selected randomly and rest others are selected at regular intervals. This was the first point. Then the second point is biasness can be there. It is not compulsory that it will always be there, but it can be there, can be present. This sample is efficient. Covers whole population. All right. These are the some of the important points of systematic sampling. And one more thing is it ensures randomness. Randomness is there because we are selecting first unit randomly. So this is it. Now, what is the outlook of this sampler, or we can say layout of this systematic sampling. First one is systematic sample number. So number goes from 1 to I k. Then is sample composition. 1 to n. Then is probability, and the last one is mean, or we can say sample mean. So this is the table that we will create. Now, first sample will be y1, second will be y2, ith will be yi, and this one will be yk. Now again the sample would be y1 plus k, yk plus 2, yk plus I, and y2k. And similarly, this will be yi plus yn minus 1 into k plus 1, yn minus 2 into k plus 2, yn minus I into k plus I up till yn k. So probability of selecting every sample is equal in this case because it is a special case of simple random sampling. So probability of selection of every unit is 1 upon small k only. and sample mean. First one is y bar 1, y bar 2, y bar I, y bar k. This is the layout of your systematic random sampling, and it is very important to understand the concept of simple random sampling. Now we'll do one or two examples of simple random sampling. So first of all, let us take capital N. Capital N is equals to small n is equals to k is equals to. So capital N is nothing but population size, small n is equals to sample size, and k is equals to sampling interval. And the relation between all of them is capital N is equals to small n into k. This is the relation among all of them. So first example is, let us take an example of we have to conduct an experiment on 100 students. Like, let's take the same example. A school has 1000 students and we have to take out the sample of 100 students. And our integer, what will be our integer? Uh, what do we say? Sampling integer interval is nothing but capital N upon small n, which is 1000 upon 100, which is nothing but 10. So if there are 1000 students, suppose, and I am taking I as, we have to choose I, that is first unit randomly from 1 to 10. I am taking I as 9, suppose. So our systematic sample would be 9, 9 plus 10, 19, 19 plus 10, 29, 29 plus 10, 39, 39 plus 10, 49, 49 plus 10, 59, 59 plus 10, 69, 69 plus 10, 79, 79 plus 10, 89, 89 plus 10, 99. And these are the 10 observations or 10 samples that we get out of this. Similarly, if we take another example, where in our locality there are 30 households and we have to take a sample of 5 of them. So our sampling interval will be nothing but capital N upon small n, which is 30 upon 5, that is 6. So our sampling interval would be 6. We will choose first number randomly I, which is from 1 to 6. Let us choose it at, let I is equals to 4. Now our systematic sample would be, first one is 4, then I plus k is 10, then 16, then 22, 28. This is the sample of size 5 units. This is how this is done. Now, what are the advantages of systematic sampling over any other sampling? So, first advantage is that it is cost effective. In simple random sampling, we have to choose randomly and we have to choose from a large number of population. Here, there is a system from which we choose our sample and we have to choose the limited sample so that our cost is very less. The second one is representation of whole population. It may be biased, but it at least takes into consideration the whole population for taking out the sample. Third one is it takes less time or time consuming. Less time consuming as compared to any other sampling method, because suppose if in our locality there are 30 houses and we know that we have to visit only 5 houses, and we fix that this house number, then this house number, and this house number we have to go, then we'll not waste our time going to random houses or randomly going to any houses. So we'll directly go to that number of houses. One of the major disadvantages is that if some of the houses told us not to come, or that those blank spaces will be created in between, and that is not a good that does not give good results for systematic sampling. So this was the basic of systematic sampling. We'll discuss the estimation on variance from in tomorrow's lecture. Till then, keep on working hard with consistency and keep on taking the lectures regularly, so that we'll be able to complete the course in time and we'll have ample of time to revise. All the best. Thank you.